Hello, sir. Good morning, Toronto. This is Kinship. I'm from ECB section, and my roll number is 21951 And today's my topic is atom thick transistor. First of all, we know about transistor. A transistor is a miniature semiconductor that regulates or controls current or voltage flow in addition, amplifying and generating these electrical signals and acting as a switch gate for them. Typically, transistor consists of three layers or terminals of a semiconductor materials, each of which can carry a current. And what is a transistor and types? A transistor are broadly divided into three types: bipolar transistor, bipolar junction transistor (BJTs), field effect transistors (FETs), and the insulated gate bipolar transistors (IGBTs). Transistors semiconductor devices for amplifying, controlling, and generating electrical signals. Transistors are the active components of integrated circuits or microchips, which often contain billions of these minuscule devices etched into their shiny surfaces. Why transistor is called a transistor? The word transistor is a combination of transfer and resistance. This is because it transfers the resistance from the end of the devices to another end of, or we can say transfer the resistance, hence the name transistor. Transistor have very high input resistance and very low output resistance. The word transistor is a combination of transfer of resistance. This is because it transfers the resistance from one end of the devices and to the another end, or we can say transfer of resistance. Hence the name transistor. Transistors have very high input resistance and very low output resistance. Step 1. Step aside, graphene silicon is the trendy new nano material in town that could one day supercharge future tech. Scientists have created the world's first transistor out of the silicon-based material, and it's the mere atom thick, unlike its much malignant graphene cuisine, which has yet lived its vast potential. Silicon is a much more interesting material for computer scientists. Thanks to the silicon base, it came from band gaps necessary for transistors, which could one day lead to faster chips that consume less power. Defeat came as surprise to many observers, despite the fact that the chip only lasted a few minutes due its instability. Up there recently, silicon was only a theoretical material, and nobody expected a transistor to be built from it anything soon. But the team succeeded by condensing an atom-thick layer onto the block of silver in a vacuum, then sealing it in a aluminium. Afterwards, they peeled away the silicon material from the silver black, leaving thin layers of silver and aluminium as protection, scratching away portions of the silver resulted in a rudimentary but functional transistor. The scientists planned to hone the processor to create longer lasting functional chips in the near term. However, there's still some serious barriers given the instability of the silicon in the real world and difficulty in working with it. But as one scientist said, the major breakthrough here is the efficiency, lower temperature, manufacturing and fabrication of silicon device for the first time. That's still quite a feat. But whether it leads to useful gadgets or not is a wide open question. How big a transistor in atoms? The atomic size of a common semiconductor materials are the size of a semiconductor material is 2 nanometers. Suffice it to say it would be impossible to create a silicon transistor smaller than that. How thick a transistor is. The size of the transistor element continuously decreases in order to pack more the chips. In 2001, a transistor commonly had dimensions of 0.25 micron or micrometer. 1 micron is equals to 10 power minus 6 meter, and 0.1 micron was projected on 2006. How many atoms in is the smallest transistor? But in June, Intel researchers led by Robert Chow reported making a standard three-terminal transistor, the architecture used in today's chips, with the smallest features ever reported, including an insulting barrier only 3 atoms wide. An image of the template of the quantum dot device showing a central core. The 7 phosphorus atoms are incorporated. The atom-thick transistor. There's a new contender for the world's thinnest piece of electronics, and the 3 atom thick. It's going to be the Great Harder beat. They say researchers have discovered a new process of producing ultra-thin transistor. According to a paper published today in Nature, the devices are made from the experimental material known as a transition metal dichalonide, and also called the TDM. TDMs are exciting because they're so thin, usually appearing as films the of these just few terms, with properties that make them useful for building solar cells, light detectors, and semiconductors. It's an exciting prospect for physicists and manufacturers alike, but making the materials work consistently has proved extremely difficult. Today's result unearths the best process yet for manufacturing the materials, giving new hope that the material might someday give rise to automatically the thin circuits and sensors. Our work pushes TMDs to the technological relevance scale, showing the promise of making devices on this scale, said Sainz from the Japan scientist, one of the lead author paper principle there no barriers to words. The Nature paper detailed a new way of producing TMD, more successful and stable than any previous method. The researchers turned to a potent industrial technique as known as metal organic chemical vapor deposition, or MOCVD. The process starts with two commercially available prosecutor compounds, sulfide and a metal hydrochloride compound mixture on a silicon wafer and baked at 550 degrees Celsius for 26 hours in the presence of hydrogen gas. The result was an array of 200 ultra-thin transistors there with good electron mobility and few of defective. Just two of them failed to conduct, leaving researchers with a 99% of success rate. It's the best production result TMDs have had so far, suggesting the material might one day be used to make ultra-thin electronics. Still, the next step is making sure it can be produced consistently. The report of the new properties is important in order to understand the material, but there is a lack of systematic research on synthesis methods, said Humberto Gutierrez, a physicist at the University of Louisville who also works on ultra-thin materials and was not involved in the paper. Many of the reported conditions using chemical vapor deposition cannot be produced from the laboratory to another, and the larger area films have very low crystal quality. So hammering of those inconsistencies there is a crucial if researchers are going to build workable device out of the new materials, the researchers will also need to produce able to produce TMDs at the lower temperature if they are going to be used in conventional electronics, as many auxiliary materials will combust at 550 Celsius. Still, the biggest concern now is simply expanding the current results. If researchers can produce the ultra-thin transistor consistently, there will be lots of opportunities to refine the process in future. Thank you for giving this wonderful opportunity, sir.